any two geometrical figures which are same in shape and size, then that kind of the figures are called as congruent figures. For example, two equilateral triangles with same length, of the sides, or two circles with same radii, or two line segments having equal lengths, right? So these are some examples related to congruence. The next one, we discussed some congruence criteria of the triangles. For example, the first one is SSS criteria, second one SAS criteria, third one ASA criteria, and fourth one is RHS criteria. Here you are observing these two are the congruent chalks, right? Because these two chalks are having equal length and the shape of these two chalks is also same. So these kind of the figures are called as congruent figures. In SAS congruence, how you can define the SAS congruence? The three sides of one triangle is equal to the three sides of another triangle, then the two triangles are said to be congruent by using SSS congruence criteria, right? So these are all things we already discussed in the previous sessions. In this session, I am going to discuss some theorems and problems based on that congruence criteria. Okay, see the first question. If in the given figure shows a circle with center O, P is a midpoint of the chord, AB, show that OP is perpendicular to AB. OP is perpendicular to AB. So O is the center of the circle and AB is a chord. Here AB is a chord and O is the center of the circle. OP, the line drawn from center of circle to chord. OP is the line which is drawn from center of circle to chord. Here you need to prove that this OP is perpendicular to AB. Okay. First, write the given things. What are the given data here? AB is R, a circle with center O, and AB is a chord, right? Next, what you have to prove here? You need to prove that OP is perpendicular to AB. OP is perpendicular to AB. Proof. Before proof, you need to construct some parts. Construction. Join OA and OB. Just join these 2 points, OA and OB. What it indicates here, OA and OB? OA and OB are the two radii of the given circle, because these lines are drawn from center of circle to circumference. So OA and OB are the two radii of circles. Okay. Next, by joining these two lines, OA and OB, we are getting two triangles here. What are the two triangles? Triangle AOP and triangle BOP, right? So these are the two triangles AOP and BOP. In that, OA is equal to OB. What you have to write the reason here? These two are radii of circle, or radii. In the given particular circle, if you are drawing infinite number of radius, all the length of that radius should be same. because all these radius are the equidistance from the center to the circumferences. Okay, so OA is equal to OB here. What is that next one? OP is equal to OP. OP is equal to OP. This is the common side. OP is equal to OP. And one more word is given, that is P is the midpoint. If P is the midpoint of the line segment AB, means that P will divide the line segment into two equal parts, and the two equal parts are AP is equal to BP. AP is equal to BP. So AP is equal to BP. AP is equal to BP because P is a midpoint of AB. P is a midpoint of AB. Therefore, triangle AOP, which is congruent to the triangle BOP, by using the congruence criteria SSS. Here we are taking three sides, that's why the two triangles are congruent by using SSS criteria. Once we prove that the two triangles are congruent, means remaining all corresponding angles and sides are equal by using CPCT, corresponding parts of the congruent triangles. Therefore, angle OPA is equal to angle OPB. Angle OPA, which is equal to angle OPB by using CPCT. Right? Once we prove that these two angles are equal, means take that two angles, angle OPA plus angle OPB, which is equal to 180 degree, because the sum of these two adjacent angles will form a linear pair. Right? Angle OPA and OPB, these two angles are originated from the same point P, or two angles are having one common point, that is the P point. At point P, it makes an angle 180 degree. So we already proved that angle OPA is equal to OPB. Either you can take here OPA plus OPA or OPB plus OPB. Right? Angle OPA plus angle OPA, which is equal to 180 degree, because we already proved that angle OPA, which is equal to angle OPB. Right? Angle OPA plus angle OPA means 2 times of angle OPA, which is equal to 180 degree. Angle OPA is equal to 180 divided by 2. Here the angle OPA is equal to 90 degree. If angle OPA is equal to 90 degree, means angle OPB is also equal to 90 degree. So if one in linear pair, if one angle is equal to 90 degree, means other angle is also 90 degree. Right? So angle OPA and angle OPB are 90 degree each, means it indicates that the line drawn from the center of circle to the chord, that is OP is perpendicular to AB. OP is perpendicular to AB. So hence we proved the given statement. What we proved here? The line drawn from center of circle to the any chord which is always perpendicular one, right? And it bisects the chord into two equal parts also. Okay. Next one we'll discuss in the next question how the line OP will be bisect the chord into two equal parts. Okay. So this is the proof of the first question. Next, second question. In figure, same diagram only. Already told you in first theorem, in first question we need to prove that OP is perpendicular to AB. In this question we need to prove that OP, what we are drawing the line from center of circle to chord, no, that chord will be bisected into two equal parts. It means we need to prove that the length of AP is equal to BP. Okay. In the given figure, if OP is OP is perpendicular to AB, prove that AP is equal to BP. AP is equal to BP. So figure is same. This is the second question. Same figure. Given is also same. What is that given data? A is a circle with center O. A circle with center O. AB is a chord, and one more point they gave already here, that is OP is perpendicular to AB. OP is perpendicular to AB. What you need to prove here? You need to prove that when the line drawn from center of circle to chord, the chord will be bisected into two equal parts. It means AP is equal to BP. You need to prove that these two lengths are equal. Okay. So next one, construction part. Construction is also same. Just join the line from O to A, O to B. It means join OA and OB. Join OA and OB. Here OA and OB are nothing but these two are the radii of the circle. Next one, proof. By joining that two lines OA and OB, we are getting here two triangles, triangle AOP and triangle BOP, right? So in that OA is equal to OB, OA is equal to OB, because these two are the radii of circle. Next one, OP is equal to OP, OP is equal to OP. Here OP is a common side for these two triangles, right? Next, if OP is perpendicular to AB means it will form a 90-degree angle at point P, right? So angle OPA is equal to angle OPB, angle OPB. Each angle is 90 degree. Therefore, triangle AOP, which is congruent to the triangle BOP, by using which criteria you are using here? If angle OPA or OPB is 90 degree means the side which is opposite to the right angle is always hypotenuse. So OP is one of the side of the right angle triangle. It means here you are using RHS criteria. From RHS criteria, these two triangles are equal means the remaining all angles and all sides are equal. Therefore, AP is equal to BP by CPCT, by using CPCT. Once we prove that two triangles are equal means the remaining all sides and angles are equal by CPCT, corresponding parts of the congruent triangles. Okay. Next, see the third question. In third question, the perpendicular bisectors of the side of a triangle ABC meet at I. Prove that IA is equal to IB is equal to IC. IA is equal to IB is equal to IC. Third question. This is the diagram of the third question. In triangle ABC, the perpendicular bisectors of the sides of a triangle ABC meet at I. So you need to draw three perpendicular bisectors, AD, BE and CF. These three are the perpendicular. Perpendicular means it makes a 90-degree angle at the point of intersection, and it's not only perpendicular, it's the perpendicular bisectors. Bisectors means it will divide the line segment at what point it is intersected. No, it will divide the line segment into two equal parts here. So these two equal parts, the side AC, these two are the two equal parts. In this one, AF is equal to FB, right? So it will divide the line segment into two equal parts. First write the given. What are the given datas here? In triangle ABC, AD is perpendicular to BC. AD is perpendicular to BC. Next one, BE is perpendicular to AC, and last one, CF is perpendicular to AB. AD is perpendicular to BC, BE is perpendicular to AC, CF is perpendicular to AB. So these are the perpendicular bisectors drawn from the vertices of the triangle to the opposite sides of the triangle. Okay. So what you have to prove here? You need to prove that IA, all these perpendicular bisectors are meet at one point, that is I. So you need to prove that here IA is equal to IB is equal to IC, right? Listen here. Here in triangle, by intersecting these three perpendicular lines, what we call this one point? Orthocenter, because these three are the perpendicular bisectors, right? So orthocenter, I is a orthocenter here. What you need to prove? IA is equal to IB, IA is equal to IA is equal to IB is equal to IC. So consider the triangles, the two triangles BID. Proof. When I draw the line from point A to the base BC, D will divide the line segment BC into two equal parts, and two equal parts are BD and CD, right? So first consider these two triangles. In triangle BID and triangle CID. This is BID and CID. In that ID is equal to ID. It is a common, or you can also take it as a ED is equal to ED. ED is equal to ED, or ID is equal to ID. ID is equal to ID. Common. Right? Next one. BD is equal to CD. BD is equal to CD because D is a midpoint. D is a midpoint. Next one, angle IDB. Angle IDB, which is equal to angle IDC. IDC. Each angle is 90 degree. Therefore, triangle BID, which is congruent to the triangle CID, by using RHS criteria. By using RHS, sorry, which criteria are you using here? You are not taking here hypotenuse. It means by using SAS, two sides and one angle. By using SAS criteria, the two triangles BID and CID are congruent to each other. Once we proved that these two triangles, triangle BID and CID are equal, means the remaining all parts are equal, no? Therefore, IB is equal to IC. IB which is equal to IC by CPCT, by CPCT. Consider this one as a equation 1. Equation 1. Now similarly, take these two triangles. Triangle CIE. Similarly, in triangle CIE and triangle AIE. What are the equal things here? IE is equal to IE. IE is equal to IE. This is a common side for both these two triangles. Next one. AE is equal to CE. AE is equal to CE. E is a midpoint. E is a midpoint of the side AC. Next one. Angle IEA, which is equal to angle IEC. Each angle is 90 degree here, right? Therefore, triangle CIE, which is congruent to the triangle AIE, by using the same criteria SAS, right? So once we prove that these two triangles are equal, means the remaining parts, what are the remaining parts here? Well, we already consider AE is equal to CE and IE is a common side for these two triangles. So remaining sides are IB, IA and IC. So IA is equal to IC by CPCT. By using CPCT, IA is equal to IC, right? So consider that one as a equation 2. Now one more triangle is there here. The two pair of triangles are remaining in this diagram. What are the triangles? Triangle AIF and BIF, right? So in triangle AIF and triangle BIF, again you need to write the equal things. What are the equal things here? AF is equal to FB, because here F is a midpoint. F is a midpoint of AB. Next one. IF is equal to IF. It's a common side for these two triangles. Next, angle IFA is equal to angle IFB. Each angle is 90 degree, right? So triangle AIE, which is congruent to the triangle BIF, by using the criteria SAS. So again here two triangles are equal and their remaining parts are IA is equal to IB. IA is equal to IB by CPCT. Consider this one as a equation 3. Now just observe the equation 1, 2 and 3. What we are getting in equation 1? IB is equal to IC. In equation 2, that IC is equal to IA. Again this IA is equal to IB, means we already know that in the previous classes from Euclid's axioms, equal things are equal to one another. It means if I take these two chalks, length of these two chalks are same, no? Here I am taking one more chalk, and once I add these two things, the same part, once I add for these two chalks, again I will get the same length of two chalks. Or here I am taking two chalks having same length, by adding two more chalks for these two, I will get the two equal length chalks, right? So it means things which are equal to the same things are equal one another. So from equation 1, 2 and 3, IA is equal to IB, IB is equal to IC. So this is the required proof of the given statement. It means here IA is already equal to IC. This IC is equal to IB. That IB is equal to IA. So equal things are equal to one another. Therefore, IA is equal to IB is equal to IC. This is the required proof of the given statement. Next one. See the fourth question. So just you need to practice these type of questions. You will get some ideas how. And one more thing, when you are going to be show any two triangles are congruent, means in sometimes we need to consider direct two triangles. With the help of the figures, we can directly consider the two triangles. In that only we will get two equal angles or two equal sides and one angle, two equal sides and one equal angle, or two equal angles and one side. So whenever you are going to be simplify these kind of the problems, just consider the triangles directly, right? Now see the next question. Fourth one. In the given figure, AB is equal to, first write the given things. AB is equal to DB. AB is equal to DB and AC is equal to DC. Angle ABD is equal to 58 degree. Angle DBC is equal to 2x minus 4. Angle ACB is equal to y plus 15. And one more angle is given, that is angle DCB is equal to 63. Find the value of x and y. Find the value of x and y. So triangles are like this. This is point A and this one is point B, C and D. Here AB is equal to BD and AC is equal to CD, right? So first need to prove that the two triangles are equal. Solution. What we are getting here, how many triangles are there here? Two triangles. What are the two triangles? Triangle ABC and second one triangle is DBC. So directly consider that two triangles. In triangle ABC and triangle DBC. ABC and DBC. In that they already gave AB is equal to BD. AB is equal to BD. This is the given thing. Next one. AC is equal to CD or DC. This is also given in the statement. Right. Next, BC is equal to BC. This BC is the common side for these two triangles. So BC is the common side. Therefore, triangle ABC, which is congruent to the triangle DBC, by using SSS criteria. By using SSS criteria, we proved that these two triangles are equal. Clear? Now, what you have to find here? X and Y values. What are the given angles? Just observe that what are the given angles first. Angle ABD, where it lies, angle ABD, this complete angle is 58 degree. Next one, DBC, DB and C, only this angle this angle DBC is, a complete angle is 58 degree and angle DBC is 2x minus 4, right? DBC is 2x minus 4. And one more, angle ACB, this angle is y plus 15. And one more angle given, that is DCB. So this is angle DCB. This angle is 63, right? Listen here, we already proved that these two triangles are equal, no? If these two triangles are equal means their corresponding angles and remaining sides are equal. We already taken here 3 sides are equal means the remaining all their angles also equal. So angle ABC is equal to DBC, angle DBC by using CPCT, right? By using CPCT. One more angle DCB, which is equal to angle ACB. Again these two angles are equal by CPCT, right? Now how we are getting the angle ABD? This complete angle ABD we are getting from the sum of these two angles. By adding these two angles we are getting one complete angle, that is ABD. So what we are adding here? Angle ABC and angle DBC. So just add that two angles. Angle ABD is equal to angle ABC plus angle DBC, right? Here we already proved that angle ABC is nothing but the DBC. So I am directly taking here angle ABC plus angle ABC, which is equal to ABD. What is the value of complete angle ABD? 58 degree now. So that is equal to 58 degree. Now 2 times of angle ABC, which is equal to 58 degree. So DBC is given here. DBC. What is the DBC value? Angle DBC is nothing but the ABC, no? So angle ABC, or you can take directly DBC. Instead of ABC, we can take it as a directly DBC. Angle DBC plus angle DBC. So 2 times of the angle DBC, which is equal to 58. Now angle DBC is equal to 58 divided by 2, that is equal to 29. But they gave here angle DBC is equal to 2x minus 4. So 2x minus 4, which is equal to 29. Now 2x is equal to, take this minus 4 to RHS side, it becomes plus 4. So 29 plus 4, which is equal to 33. Now 2x is equal to 33 and x is equal to 33 divided by 2, that is equal to 16.5. Or you can also write it as the x value is 33 divided by 2. Now calculate the one more value, that is y. Here we already proved that angle ACB is equal to angle DCB, right? Angle ACB, which is equal to angle DCB, right? Angle DCB is already given, that is 63. Angle ACB is nothing but y plus 15. Now y is equal to 63 minus 15. 63 minus 15. So just subtract these two. Subtract 15 from 63. So what we will get? 48. Now, what are the required values of x and y? X is equal to 16.5. X is equal to 16.5 and y is equal to 48. So these two are the required values of x and y. Okay, next, see the fifth question. In this type of the question, first you need to show that the triangles, what they are given now, the triangles are congruent. Once you prove that two triangles are congruent, means you can easily find the x and y values. Next question, if AP bisects angle BAC and M is any point on AP, prove that perpendicular drawn from point M to AB and AC are equal. Fifth question, here BCA, angle BAC. This angle is bisected from the ray P. So P is a line, or AP is a line which bisects the angle BAC. Bisecting means what? The angle is divided into two equal parts. Here, what are the two equal parts? If I take M is any point on the line AP, means the two equal angles are BAM, which is equal to CAM. And from this point, if I draw the two perpendiculars to the side AB and AC, the two perpendicular sides are MN and ML. MN is perpendicular to AC and ML is perpendicular to AB. So what you have to prove that here? What you need to prove? MN, the line drawn from, the perpendicular line drawn from point M to the side AB and AC are equal. It means you need to prove that MN is equal to ML. So first write the given things. What are the given data here? AP is a line. Bisect the angle BAC. And one more, ML is perpendicular to AB and MN is perpendicular to AC. So these two are the perpendicular line drawn from the point M, right? Next, what you have to prove here? The distance from point M to N and from point M to L are equal. It means you need to prove that MN is equal to ML, right? Now, prove the given statement. By joining these two lines, what you are getting here? Again two triangles. What are the two triangles? First triangle is ABM and ANM. So first triangle is in triangle ALM and triangle ANM. In that AM is equal to AM. This is the common side for these two triangles. Next one, angle NAM is equal to angle LAM, because here AP bisects angle A or angle BAC. The line AP bisects this complete angle. It means the complete angle A is divided into two equal parts. And next one, AL, AL which is equal to AL which is equal to R. You can take here angle ALM, angle ALM which is equal to angle ANM. What you are observing here at the angle L? What you are observing? Angle L is also 90 degree, angle N is also 90 degree. So these two angles are 90 degree each. Each angle is 90 degree. Therefore, the triangle ALM is congruent to the triangle ANM by using the criteria AAS. What is that new criteria? AAS? AAS is the one of the form of the criteria that is from the congruence criteria ASE. It means in any triangle, if you are taking two triangles, means if sum of two angles or any two angles are equal, means the third angle is also equal by using the angle sum property of the triangle. For example, if I am taking the two triangles, this is 50 degree and this one is a 60 degree. Here I am taking 60 degree and this one is a 50 degree. So whether these two angles are equal or not? Yes, these two angles also equal, because once we take two angles are equal in two triangles, the third angle is also equal by using the angle sum property, because the total interior angle of any triangle is always equal to 180 degree. Just add these two angles. 50 plus 60 is 110. 180 minus 110 is 70 degree. Here also 50 plus 60 is 110. Just subtract this 110 from 180. What you will get? 70 degree. So these two angles are 70 and 70. So it means by using AAS criteria, the two triangles are equal. So how we are going to be state the criteria AAS? AAS is one of the criteria obtained from the congruence criteria of the triangle, that is ASA. So this criteria is defined as like this. In two triangles, in any two triangles, two angles and one side are equal in one triangle. The same two angles and one side is equal in another triangle, then that two triangles are said to be congruent by using AAS criteria. So here we proved that the two triangles are equal, means then the remaining all parts, whether it may be sides or angles, are equal. So MN is equal to ML by using CPCT. So this is the required proof, right? What we need to prove here? Mn is equal to Ml. Here we proved that Mn is equal to Ml. This is the required proof of the given statement. Next, see the next question, sixth one. AAS is one of the congruence criteria. This is another form of the ASA. Okay, next, sixth question. A line segment AB is bisected at point P, and through point P another line segment PQ which is perpendicular to AB is drawn. Show that QA is equal to QB. Means here AB is the base of the triangle. AB is the base of the triangle and Q is the opposite vertex. Q is the opposite vertex to the side AB. If I draw the line from opposite vertex to the base of the triangle AB, so PQ is the line here. PQ is a perpendicular line. PQ is a perpendicular bisector. right? So here you need to prove that QA is equal to QB. So first write the given datas. What are the given datas? QP is perpendicular to in triangle QAB. QP is perpendicular to AB. QP is perpendicular to AB, right? Next one, what you have to prove? You need to prove that AQ is equal to BQ or QA is equal to QB. Proof. By joining the line from Q to P, perpendicular line from point PQ to P, we are getting two triangles. So what are the two triangles here? Triangle AQP, and triangle BQP. So these are the two triangles, triangle AQP and BQP. In that, PQ is the common side. PQ is the common side. PQ is the common side for these two triangles. Next one, AP is equal to BP. AP is equal to BP. Because here P is a midpoint. P is a midpoint of AB, or the line drawn from Q to P. QP is perpendicular to AB, and it's not only perpendicular, it will be bisect the line AB into two equal parts. Next one, angle QPA, which is equal to angle QPB. Each angle is 90 degree. Each angle is 90 degree. Therefore, triangle AQP, which is congruent to the triangle BQP by using the criteria SES. So once we prove that two triangles are congruent, means then the remaining all parts are equal. So AQ is equal to BQ by using CPCT, or you can also write it as QA is equal to QB by using CPCT. Next one, see the next question, 7th one. In triangle ABC, AB is equal to AC. 7th one, ABC. In triangle ABC, AB is equal to AC. These two sides are equal. Show that the altitude AD, altitude means perpendicular line, altitude AD is a median also. So here you need to prove that AD is the altitude. That altitude you need to prove that AD is a median also. So what is the difference between median and altitude? Altitude is the line. Altitude is the line which is perpendicular to the opposite side of the triangle. The line drawn from opposite vertex to the opposite side of the triangle is the altitude, which is always perpendicular, but median means the line which divides the triangle into two equal parts. Clear? Median divides the triangle into two equal parts, whereas altitude is always perpendicular. Now, first write the given datas. What are the given datas here? First one is in triangle ABC, AD is perpendicular to BC. In triangle ABC, AD is perpendicular to BC. So what you have to prove here? You need to prove that AD is a median. AD is a median of the triangle ABC. Okay. So by drawing this perpendicular line, we get here two triangles. What are the two triangles? Triangle ABD and ACD. In triangle ABD and triangle ACD. Triangle ABD and ACD. AB is equal to AC. They are already given here. AB is equal to AC. Next one. AD is equal to AD. AD is equal to AD. This is a given thing. And AD is equal to AD is a common side for that two triangles. And next one, angle ADB. Angle ADB is equal to angle ADC. Here each angle is 90 degree, right? Therefore the triangle ABD, which is congruent to the triangle ACD. So which property you are using here? Yes, yes, right? Or you can also use AAS, right? So these two triangles are congruent by using the criteria AAS. Okay, so once we proved that two triangles are congruent, means the remaining sides are equal, no? So what are the remaining sides? We already taken here. AB is equal to AC and AD is the common side. The remaining side is BD is equal to CD. BD is equal to CD. These two are equal sides by using CPCT. Just observe this one. BD is equal to CD means, if BD is equal to CD means D is act like a midpoint. D is act like a midpoint. So the line drawn from the opposite vertex to the base of the triangle is called as a median. So here AD is the, if BD is equal to CD means D is a midpoint. D is a midpoint of the side BC. Therefore AD is a median of the triangle ABC. AD is the median of the triangle ABC because it divides the triangle into two equal parts. What are the two equal triangles here? Triangle ABD. It's the first triangle which is equal to the second triangle ACD. These two are the two equal triangles. Next one. See the next question. Eighth one. In the following figure, some given datas are there. First write that given datas. BL is equal to CM. BL is equal to CM. Prove that AD is the median of the triangle. What you need to prove? You need to prove that AD is the median of the triangle ABC. Median of the triangle ABC. So figure is like this. BC is the one line. This is point A and this one is point D. CM is perpendicular here also. BL is perpendicular, right? So this is the given diagram. From this diagram you need to prove that ED is the median of the triangle ABC, right? Now what are the given data here? BL is equal to CM and BL is equal to CM, right? So now consider the two triangles. The two triangles are BLD and CMD. Proof. In triangle BLD and triangle CMD. These two are the right angle triangles, right? So in this, BL is equal to CM. They already give. BL is equal to CM. This is already given in the statement. Next one. Angle BLD which is equal to angle CMD. Why? Because these two angles are 90 degree. Angle CMD, each angle is 90 degree. Next one, two side lines. When two lines are intersect, it will form a vertically opposite angles. Two pair of vertically opposite angles. So angle BDL which is equal to angle CDM. These two angles are equal by vertically opposite angles. Therefore, triangle BLD which is congruent to the triangle CMD by using the criteria AAS. Right? If two angles, in any two triangle, if two angles are equal means the third angle also equal with the help of the AAS or with the help of the angle sum property. So once we prove that two triangles are equal means their corresponding sides are equal. So what are the corresponding sides here? We already taken BL is equal to CM. What are their corresponding sides? So BD is equal to CD. BD is equal to CD. BD is equal to CD. Just observe these two sides. BD is equal to CD means these two are the two parts of the base of the triangle BC. It means the BC is divided into here two equal parts, BD and CD. So D is act like a midpoint. D is a midpoint of the side BC. If D is a midpoint of the side BC means the line drawn from the opposite vertex A to D is a median. So AD is a median. AD is a median of the triangle ABC. Hence we proved the given statement, because whenever the line drawn from opposite vertex to the base of the triangle, if it divides the base into two equal parts means the line will be act like a median. Okay, just practice these type questions. In the next class we'll discuss some more problems. Until then, happy, take care, thank you for watching video.